Today we have with us Ms. Payel Das, who is doing her PhD in the University Hospital of Erlangen, Germany.
So today I would be talking about my PhD work that I have been doing for the past 2.5 years. So I work on the heart, of course. So because we have a lot of non-biologists here with us today, so I would take you to the basic concepts of biology, some of the basic concepts before moving into the technical part of my PhD work. This is a cross-section of a heart muscle and a skeletal muscle taken by a light microscopy. So when muscle contracts, there is a region where the two filaments interdigitate with each other, which is known as the Z disc, as marked by the arrow here. Each individual heart cell needs to beat in synchronous so as to give the proper functionality of the heart. In case of skeletal muscle, each intact muscle fiber usually has resident stem cells present in them, which are known as satellite cells. A very severe massive heart attack, what happens is your ventricles, they are the lower portion of the heart, your ventricles are the most affected. So you lose a lot of cardiomyocytes. That is, a lot of cardiomyocyte death take place. So you differentiate induced pluripotent stem cells into cardiomyocytes, and you can individually inject these cells into this infarct area of an heart. But the problem is when you inject these cells, just individual cells, there is always a chance that the cells would die before they even reach this infarct. Scientists actually were able to 3D print the heart externally. This is that heart. It's a rabbit heart. When the cells differentiate or they become more specialized, the centrosome is disassembled. That is, the centrioles move apart from each other and the PCM components dissolve into the cytoplasm. In case of neurons, it is the axons which become the new NC, MTOCs. These blob-like patterns are basically the centrosome, and with it, the red dot co-localizes with this green-like blob-like structure, which basically indicates that there is a centrosome present in an embryo, in a fetal cardiomyocyte, and that there is microtubule as well. They are capable of maintaining the centrosome throughout their life. You can purposefully create an infarct in a zebrafish heart, and once you do it, the zebrafish heart has the propensity of regenerating itself even at the adult stage. First of all, I would like to thank obviously my professor 𝗏𝗏 and a very big thanks to Robert. This is Robert at the center. He's the one who actually taught me to do these experiments. He was the one who first helped me how to interpret data in these, because I had no idea how a centrosome looked like before I joined this lab. So Sylvia is a postdoc in my lab who did a lot of the work in the paper that I just showed, and the rest of the people who are extremely kind and they help me whenever they want to. So if you come to this lab, you will see that it's a very happy group. They support each other a lot.
Is there any other protein which is present in the centrosome which gets relocated from centrosome to the perinuclear envelope to develop microtubules? So I was thinking that, so I was asking this question because I don't know anything about it.
Yeah. Okay.
Maybe there is some protein. I think there is a gamma tubulin.
Yeah.
So the gamma tubulin.
Exactly. So this is a very good question. So yes, there are certain proteins which are specific to the nuclear envelope. I cannot disclose the name right now because the paper is in review. So, but yeah, there are certain proteins that we did find out, like Sylvia actually found out that there are certain proteins which are responsible for bringing these centrosomal components from the centrosome to the nuclear envelope. And once these centrosomal components redistribute to the nuclear envelope, it actually functions exactly like the centrosome. You have gamma tubulin, you have alpha tubulin, you have everything that usually a centrosome has, but a nuclear envelope also has some other components which are essential to establish this nuclear mTOC. So, thank you guys for listening. Thank you for all the questions. They were lovely, and I hope you enjoyed the session. And so Shubho and Ani told me to talk a bit about PhD and PhD experience. So I'll just say this, that if you want to do a PhD, just go for it. Don't think much. It's not about like you know, it is the satisfaction that you get at the end of the day. So I will just share one incident with you. So I did not have a single piece of data for 1.5 years in my PhD. So, and after that, the day when I got my data, and that was the most like the happiest day of my life. So if you want to do a PhD, stick to it. I know there will be many hard days, failed days, failures, and it will, out of 365 days, probably 350 days are failures, but those 15 days that you get in the entire year makes it worth it, trust me. So do not give up at any point of time. And if you do not want to do a PhD, that's also fine. You don't have to do a PhD. It's just another degree. But if you do want to do it, just believe in yourself and you will be just fine. It's fine. And the days you get your result, the day you see your name on that paper that you publish, it will be worth it. I'm telling you, it will just be worth it. Thank you.
So if you're a researcher and if you are interested in sharing your work with the rest of the world, you can make use of this platform. There are two possibilities right now. You can give a live webinar session, or you can be a part of our semi-technical research blogs that we are publishing periodically for the rest of the audience to know what is actually happening in the field of science and technology.